So moving on to multiplication, we're going to start off with something a little simpler and then we're going to make it a little bit more complex. So if matrix A is denoted by A sub ij, it's an m by n matrix, and C is a scalar, meaning it's just some really integer. The scalar multiple of A by C is the m by n matrix given by C times A equals C times A sub ij. That's a lot of notation for something that's really not that complicated. If anything, I'd say it's even easier than what we did with addition. So, for example, if I were asked to do 3 times A, in other words, we're going to take this whole matrix and multiply it by 3. Really, we're just going to go term by term and multiply every one of those terms by 3. So kind of starting off up here, 2 times 3 gives us 6. Moving across that row, the next 2 times 3 is also 6. And at the top of the row, 4 times 3 is 12. So that's the end of row 1. We're moving on to row 2. Negative 3 times 3 is negative 9. 0 times 3 is 0. Negative 1 times 3 is negative 3. Final row, 2 times 3 is 6. 1 times 3 is 3. 2 times 3 is also 6. And that's it. So I'd even say that's a little easier than addition. I mean, maybe it's the same difficulty, whatever. It's not super complicated. The next part's going to be a little bit more complicated. We have to pay attention a little bit more to some details. So another basic matrix operation is we call matrix multiplication. So what that means is we're actually multiplying matrices by each other. So for the product of two matrices to be defined, the number of columns, so the number of columns, the up and down ones in the first matrix must be equal to the number of rows in the second matrix, the horizontal ones. This means, as a result, that matrix multiplication is not necessarily commutative. That is to say, you might be able to do A times B, but not B times A. Commutative. Sorry, I forgot about spelling for a second. So we're asked to, on example 6, find the product of AB using matrix A being negative 1, 3, 4, negative 2, 5, 0, and matrix B is negative 3, 2, negative 4, 1, sorry, and yeah, negative 4 and 1. Now, in order to do this, we're going to do, I'm going to write it as A times B, sorry, waiting for AirServe to catch up, there we go, equals AB. And in order for us to do A times B, we have to identify the dimensions. So A matrix is 3 by 2, and matrix B is a 2 by 2. Now going back to what we talked about at the beginning of this little piece, or this part right here, the number of columns in the first matrix must be equal to the number of rows. In other words, when you're lining them up next to each other, these two, let me change colors, these two must be equal. Oops, sorry. These two must be equal. I can't spell. Must be equal. If they are not equal, you're not going to be able to multiply them together. Now, these outer numbers are going to be the products, the output of what we got when we multiply order. So if you want to know how big our new matrix should be, look at the outer numbers. So our new matrix is going to be a 3 by 2 matrix. Now, when we're multiplying matrices, the overall goal is to do row, and then I'm going to say by column. Oops, sorry. Column. So what we're going to do is we're going to take the rows of one matrix. So I'm going to rewrite this first matrix, which was, let's see, matrix A was negative 1, 3, 4, negative 2, 5, 0. And matrix B was the matrix negative 3, 2, negative 4, 1. And we're going to go through and multiply every row by every column. So I'm just going to kind of highlight a couple things here. We're going to start off by multiplying this row by this column. Now, what does that look like? So when we're doing this, we're going to take row 1 of the first matrix, equals row 1 of the first matrix and multiply by the individual terms of the second matrix. So we're going to start off with negative 1, and maybe I shouldn't use the writing tool, negative 1 times this negative 3. And I'm actually going to write that out. So we have negative 1 times negative 3. And then we're going to add it to the second row, or the second term in that row, by the second term in the column that we're multiplying it by. So we're going to do 3 times negative 4. So we got plus 3 times negative 4. And that's going to be our input, and that's going to be like the sum of that is going to be the input in row 1, column 1 of our final matrix. Now moving on, I'm going to do that same row, that negative 1, 3, but instead we're going to multiply it by the second column in the second matrix. So we're still going to take the negative 1 from that first row of that first matrix, and we're going to multiply it by the first term of that row in the second matrix, in this case the second row, so we got times 2. And then we got plus the second term in the first matrix is 3, and multiply by the second term in that column of the second matrix of 1. So that takes care of multiplying row 1 by all of matrix 2, or matrix B. Now we're going to do the same thing, but now we're going to do it with the second row. So you'll start to notice there are some things that are going to kind of stay the same in all of these, and hopefully the color coding that I'm using is going to help you identify that. So we're going to take the second row, pardon me, got a tickle in my throat, and multiply by the columns in the second matrix. So we're going to do 4 times the first term in that first column of the second matrix times negative 3 plus negative 2, that second term in that row, times the second term in that column of the second matrix of negative 4. Then we're going to do the same thing with that row, that same row, so we got 4, and we're going to multiply it by the first term in the next row of the next matrix, so that'll be times 2, plus the second term of that row from the first matrix, negative 2, times the second term in that second column of the second matrix, holy cow, 1. Starting to notice some patterns here. You'll notice the negative 3's line up, the negative 4's line up. So everything in this first column is going to be from this first, or it's going to be related to this first column of the second matrix, of matrix B. So with that in mind, we're going to now move on to the final row of that first matrix, so the 5, 0. So we're going to do 5 times that negative 3. So still from that first column of the second row, plus the 0, that's going to be nice, times the second term of that first column of the second matrix, times negative 4. And then the last row, last of the first matrix, last row of the second matrix, we've got 5 times 2 plus 0 times 1. Folks, this is just kind of a lot of work right now. This is kind of our workspace right here. Now we're going to actually go through and simplify these. So looking at this first sum that we didn't simplify it yet, but we got negative 1 times negative 3 gets us positive 3 plus 3 times negative 4. So it's positive 3 plus negative 12. That gives us a grand total of negative 9. Next, we're going to move on to that next place, and that's that top row there. So we have negative 1 times 2, which is negative 2, plus 3 times 1. So negative 2 plus 3 gives us a grand total of 1. Now moving on to the second row, we're going to have 4 times negative 3, which is negative 12, plus negative 2 times negative 4, which is positive 8. So we have negative 12 plus 8. That gives us a grand total of negative 4. Next matrix, or sorry, next column, 4 times 2 is 8. 2 times negative 2 times 1 is negative 2. So we got 8 plus negative 2 giving us positive 6. And then finally on that bottom row, this is going to be not so painful because we have 5 times negative 3 is negative 15. 0 times negative 4 is 0. So we got negative 15 plus 0 is negative 15. And then the final 5 times 2 is 10. 0 times 1 is 0. 10 plus 0 gives us a grand total of 10. So this is our final matrix of A times B, which you'll notice has a 3 by 2 order, 3 rows by 2 columns. So let's put a box around that, and we're done with that problem.